Good afternoon, friends. Myself, Professor Sandeep Nevade, Associate Professor in Department of Electronics and Communication Engineering, Technocrats Institute of Technology. Here we are going to deliver a lecture on microprocessor and its application. The basic microprocessor is 8086 microprocessor. The salient features of this 8086 microprocessor are: first, the 8086 is a 16-bit microprocessor. The term 16-bit means that its arithmetic logic unit, internal register, and most of its instructions are designed to work with a 16-bit binary words. Second, 8086 has a 20-bit address bus, so it can directly access 2 to the power 20, that is 10,48,576 memory location. This is equal to 1 megabyte of memory, and each of this 1 megabyte of memory locations is byte. Therefore, a 16-bit words are stored in 2 consecutive memory locations. Third, it can access 2 to the power 16, that is 65,536 input-output ports. The 8086 has a 14 16-bit registers. Also, the 8086 has a multiplex address and data bus, which can reduce the number of pins needed, but it slows down the transfer of data. This is the drawback of 8086 microprocessor. The 8086 requires single phase clock with 33% of duty cycles to provide optimized internal timings. The range of the clock rates are between 5 MHz to 10 MHz for 8086 microprocessor. Next, it performs the bit, byte and word operations. 8086 operates in 2 modes, namely minimum mode and maximum mode. When only the 8086 CPU is to be used in a microcomputer system, the 8086 is used in the minimum mode of operation. In minimum mode, CPU issues the control signals required by the memory and input-output devices. In multiprocessor system, there is more than one processor in a system. The 8086 operates in a maximum mode. In maximum mode, control signals are generated with the help of external bus controller, that is 8088 bus controller. Next, the Intel 8086 supports multiprogramming. In multiprogramming, the code for 2 or more processors is in memory at the same time and executed in a time multiplex fashion. An interesting feature of 8086 is that it fetches up to 6 instruction bytes, 4 instruction bytes for 8088 and 6 instruction bytes for 8086 from memory, and Q stores them in order to speed up the instruction execution. Next, the features of 8086 microprocessor provides powerful instruction set with the following addressing mode: register addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, then indirect through an index or base addressing mode. Now, internal architecture of 8086 microprocessor. It internally divided into 2 separate functional units. One is the bus interface unit and second is the execution unit. These 2 functional units can work simultaneously to increase the system speed and hence the throughput. Throughput is a measure of number of instructions executed per unit time. Now, what is the basic function of the 8086 in internal units? First, the bus interface unit. The bus interface unit is a 8086 internal architecture to it interface the internal architecture to the outside world. It provides a full 16-bit bidirectional data bus and 20-bit address bus. The bus interface unit is responsible for performing all the external bus operations which are listed below. First, it sends address of the memory or I/O. It fetches instruction from memory. It reads data from ports or memory. It writes data into the port or memory. It supports instruction queuing, and it provides the address relocation facility. Here, this is the block diagram of the internal architecture of the 8086 microprocessor. This first is the bus interface unit, upper part is the bus interface unit, and this lower part shows the execution unit. Now to implement these functions, bus interface unit contain instruction queue. This is the instruction queue. Here this is the instruction queue. Then segment registers, instruction pointer, address summer, and bus control logic. Now what is the purpose of this instruction queue? Here we are going to discuss the instruction queue. These are the 6-byte instruction queue. To speed up the program execution, thus the bus interface unit fetches 6 instruction bytes ahead of the time from the memory. These pre-fetched instruction bytes are held for the execution unit in a group of register called queue. This is the 6 register group, and this is called as 6-byte queue. With the help of the queue, it is possible to fetch the next instruction when current instruction is in execution. This is called as pipelining. Means fetching the next instruction while current instruction executed is called as pipelining. And this instruction queue supports the pipelining architecture of the 8086 microprocessor. Here, this is the pipelining structure of instruction queue. Now, the 8086 microprocessor is having the 20-bit address lines, that is 2 to the power 20, that is 1 megabyte of memory, and the physical address of 8086 internal architecture is of 20 bit wide to access this 1 megabyte of memory location. However, its register and memory location which contain logical address are of just 16 bits wide. Hence, 8086 uses memory segmentation. It treats the 1 megabyte of memory as divided into the segment, with the maximum size of the segment is of 64 kilobytes, as the all register is of 16 bit, and 2 to the power 16 is equal to 64 kilobyte, 64 kilo. Thus, any location within the segments can be accessed using these 16 bits. The 8086 internal architecture allows only 4 active segments at a time, and this is shown in the figure. For the selection of 4 active segments of the 16-bit registers are provided within the bus interface unit of 8086, and these 4 16-bit registers are core segment register. Here this is the 16-bit segment register. These are core segment register, extra segment register, stack segment register, and data segment register. These segment registers are used to hold the upper 16 bits of the starting address of the core memory segments on which 8086 work at a particular time. For example, the value in core segment identifies the starting address of 64 kilobyte memory segment known as core segment. By starting address, we means the lowest address byte in the active core segment. The starting address is also known as the base address of that segment register. Function of the segment register. The core segment register holds the upper 16 bit of the starting address of the segment from which the bus interface unit is currently fetching the instruction core byte. The stack segment register SS register is used for the upper 16 bit of the starting address for the program stack. All stack related instructions will operate on this stack. Now, extra segment register and data segment register both are used to hold the upper 16 bit of the starting address of the 2 memory segments which are used for data purpose operation. Then some rules of the memory segmentation are: the 4 segments can overlap for small program. In minimal system, all 4 segments can start at the address of 00000 hexa. That is this is the 20-bit address locations. The segment can begin or start at any memory address which is divisible by 16. Then some advantages of the memory segmentation. As we know that the memory access capability of the 8086 microprocessor is a 1 megabyte memory. It allows the memory addressing capacity to be 1 megabyte even though the address associated with each individual instruction is of only 16 bit. Second, it allows the instruction code, data, stack and portion of the program to be more than 64 kilobyte long by using more than one core, data, stack segment and extra segment register. It facilitates use of separate memory areas for program, data and stack. It permits the program or its data to be put in different areas of the memory each time the program is executed. That is, program can be relocated, which is very useful in multi-programming operations. Now, how the 20-bit address of this 8086 microprocessor generates. Here the diagram shows the process of the 20-bit address generation. Suppose the content of the core segments are multiplied by 16. That is shifted. It shifted the content of the core segment register by 4 location. This is done in shifter register, and it is shifted by 4 position to the left by inserting 4 0 bits, and then the offset, that is the content of IP register, are added to shifted content of the core segment to generate the physical address. This is shown in the figure. The content of core segment are suppose 348A hexa. Okay, this 348A hexa is shifted 4 location from left side and 4 zeros are padded here. So the implied 0 shows that the base address of this segment memory is now 348A0 hexa. Now the offset is to be added, which is stored in the instruction pointer register, IP register. Suppose the offset is 4214. This is added in the base address of the which is shifted 4 location and 4 zeros are padded. And after the addition of these two, the physical address, which is of 20 bit, is generated. This is 38A P4 hexa. Now this is all about the execution unit. The second unit of the internal architecture of 8086 contains execution unit. This execution unit tells the bus interface unit from where to fetch the instruction or data, decode the instruction and execute the instruction which it contains. It contains control circuitry, instruction decoder, arithmetic logic unit, flag register, general purpose register and pointer and index registers. Here this is the architecture of 8086 as we seen in previous slide. This is the architecture of 8086 and this is the execution unit. Execution unit consists of these 8-bit registers which combinedly use as a 4 16-bit register also, then pointer register, source pointer, base pointer, source index, destination index, arithmetic logic unit and flag registers. Now flag register. This is the 16-bit flag register. Basically, flag is a flip-flop which indicates some condition produced by the execution of an instruction or controls certain operation of the execution unit. The flag register contains 9 active flags, which is shown in the figure. These 9 active flags are overflow flag, string flag, direction flag, interrupt flag, then trap flag, sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. These are the 9 active flag registers. Now general purpose register, as we see in the diagram, the execution unit has 8 general purpose registers, that is AL, AH, BL, BH, CL, CH and DL, DH. These registers can be individually used as a 8-bit temporary storage. AL register is also called as accumulator register, and certain part of the general purpose register can be used together to store the 16-bit data such as AX, BX, CX and DX register. Now the pointer and index registers are also used as a 16-bit register. All segment registers are 16-bit, but it is necessary to put 20-bit address on the address bus to get this 20-bit physical address one more register is associated with each segment register. ठीक है, the additional register belong to the pointer and index group are the instruction pointer register, stack pointer register, base pointer register, source index and destination index registers. Now default and alternate register assignments. This table shows the some memory interfaces and their defaults and alternate segment definition. Here, as we discussed that the 1 megabyte of the memory which is accessed by the 8086 microprocessor is segmented into 4 segments: stack segment, core segment, data segment and extra segment. And the physical address is generated by the help of this segment register. As we discussed earlier, that the 20-bit physical address can be generated by the help of this segment register and the offset register. Here, as we discussed, there are 4 offset registers. These are stack pointer register, base pointer register, source index register and destination index register. For example, the instruction code can only be stored in the core segment with IPUs as offset. Similarly, for stack operation, only stack segment and stack pointer or base pointer register can be used to give segments and offset addresses respectively. On the other hand, for accessing general data, string source, data pointed by BX and BP register, it is possible to use alternate segment by using the segment override prefix. Here, this table depicted the type of memory references, default segments, alternate segments, and it associated offset logical address. For suppose instruction fetch, default segment is core segment, and offset is stored in instruction pointer. For stack operation, default segment is stack segment, and offset is stored in stack pointer and base pointer. Then for general purpose data, the default segment is data segment. Alternate segments are core segment, extra segment, stack segment. And effective address is generated using the offset in any of the register. Source index, base pointer, source in destination index and stack pointer. Then string source, if operation related to string source, then default segment is data segment. Also we can use alternate segment such as core segment, extra segment and stack segment. Offset is stored in source index register. Then string destination operations, by default segment uses extra segment. Alternate segment is not used here, and offset is stored in data destination index register. Then BX is used as a pointer. The register BX, that is BH and BL combinedly used as a 16-bit pointer register. Then the default segment here is data segment. Also we can use alternate segments for this purpose also. And base pointer is also used as a pointer register. For this default segment is stack segment. Here base pointer, source index, destination index and stack pointer. The base pointer, you can use the base pointer register instead of stack pointer for accessing the stack using the base addressing mode. In this case, the 20-bit physical stack address is calculated from base pointer and stack segment register. The addressing mode are discussed in later sections. Now source index. Source index can be used to hold the offset of the data words in data segment. In this case, the 20-bit physical data address is calculated from source index. And now the destination index, the extra segment register points to the extra segment in which data is stored. String instruction always use extra segment and destination index to determine the 20-bit physical address for the destination purpose. This is the basic architecture of the 8086 microprocessor. Thank you.